This is chapter 14, G and H, about surface area and volume of 3D shapes. In this chapter, we'll talk about the concepts of surface area and volume. So before we start, take a moment here just to review on how you find the area of compound shapes, basically shapes that are composed of more than one shape, such as 2 rectangles, 3 squares, a triangle and a square, and so forth. And if you don't remember, here's one example to remind you. We'll look at A. So we want to find the area, and to remind you, area is the amount of space on the inside of the shape. So in this case, what I'll do is I actually will cut the shape into 2 easy shapes, a rectangle and another rectangle. It actually doesn't matter how you cut this up. You can in fact cut it this way as well if you wish. So it's really up to you, as there's no one right way to solve a problem. Once you do that, first thing you do is you want to find the area of each individual part. So this rectangle here is clearly 6 by 4. So the area of this is 6 times 4, which is 24, and it's in centimeters squared. And area is always in square units. This bottom rectangle right here, we can see is 3 here and 3 here, which means it's 6. Then you have the center, which is also 6. So 6 plus 6 makes the whole side 12 long. And remember, in rectangles, the 2 parallel sides have to be the same measurement. And the height of this rectangle is 4. So to do this one, you simply go 12 times 4, which makes 48 centimeters squared. And then finally, to get the total area of the shape, you have to add the 2 parts together. So 24 plus 48 will give you 72 centimeters squared. And that is your answer. So at this time, pause and complete the next 2. Then in the next shape, if we break it apart across, that means this rectangle is 5 by 2, which is 10. The bottom is the same. And then in the middle space, this 3 is referring to, oh, sorry, my mistake. This 3 is actually referring to the length of this side right here, which leaves this side right here to be 2. So a 2 by 3 makes this part 6. So altogether, this one should be 26 centimeters squared. In the next shape, you can choose to break it into 5 little squares, and you'll notice that each of these are all squares, so they're all 5 by 5s. So if they're all 5 by 5s, then basically each of them is worth 25. So if you do 25 times 5, that makes 125 centimeters squared. Now another way you could solve this, just to give you an idea, is to simply turn this into a whole square. This side is 15 centimeters long. This side is also 50 centimeters long because, well, it's 5 by 5 by 5. 5 by 5 by 5. If you multiply 15 times 15 together, you'll end up with 225. And then you actually have to take away the gaps. And each of these are 5 by 5s. And since there's 4 of them, and they're each worth 25, this is worth 100. So if you subtract 100 from 225, you'll end up with 125 centimeters squared as well. So that's another way to do it, just to give you an idea. And finally, the last one. You break it into 2 shapes, a triangle and a rectangle. 6 times 9, this part will be 54. And the triangle, remember the formula is to multiply the base and its vertical height. In this case, it will be 6 times 8, which makes 48. And then the last step with triangles is because it's half of a quadrilateral, you must cut it in half, divided by 2, which makes 24. So finally, you add these 2 together, 24 plus 54, which leaves you with 78 meters squared. Now to talk about surface area. Surface area, when we talk about this idea, it always refers to a 3-dimensional shape. Area addresses the 2D shape, meaning the flat surface. Surface area is basically the space around the exterior of the shape. So think about wrapping paper. Wrapping paper is applied to the surface area of a 3-dimensional shape. So how much wraps around it. The total area, and to find the surface area of a 3D shape, it's basically the total area, meaning each face, of the faces on a 3D shape. So if we look at this cube right here, because a three-dimensional shape, when it's in a box format, if it's basically a three-dimensional square, we call it a cube. If it's a three-dimensional rectangle, we call it a cuboid. Anything else that's three-dimensional, like a three-dimensional triangle or three-dimensional hexagon, we call the rest of them prisms. Okay? Now, in this case, this cube is 3, has a face of 3 by 3. So if I were to pull this out, it's basically 3 by 3. So that means this area right here is 9. Now, on a three-dimensional shape, in this case, this cube, there's 6 sides to it. There's a front, a side, and a top. That means there's also a bottom, there's the other side, and there's also the back. So to find the surface area of this cube, since the area is 9 on one face, you just simply take 9 times 6 to give you a surface area of 54. And since it's area, in this case centimeters, it is still square units. And it's wide squared because we multiply 2 numbers together, 2 sides together, 2 dimensions together. So at this time, go ahead and pause and play with this idea. And now just to warn you on B, this is a prism. It's not a normal cuboid. So you may want to think a little bit before you go through the process to find the surface area. Okay, so another way we can approach these is through the use of a net. Basically, we deconstruct a box. We open it up, just like you would when you're trying to recycle your boxes and put them in the recycling bin. So when we deconstruct it, first of all, we know that this prism, right, this cuboid has 6 sides. We have the 2 sides, we have the top, and we have the bottom. If we put the dimensions on this part is 3, the height is 2, and the length is 4. And the length is 4, and the attachment is 3. So that means we know that this side is 12, and the alternate of it has to be 12 because of the top and the bottom. And then these 2 sides are 6 because it's 3 by 2. And then finally the center, if this is a 4 and that's a 2, this is an 8 and this is an 8. Therefore, when you add these all up together, it should make 52 centimeters squared. Another way you can do this is to simply just take the faces each. This is a 3 by 2, so that makes 6. This is a 4 by 2, this makes an 8. This is a 3 by 4, which makes a 12. So if you do 6 plus 8 plus 12, that gives you 26. And that only gives you half of the sides, because remember, there's also the other side, the left side, the bottom, and the back. You actually have to take the 26 and you double it because there's 6 sides in this shape, which gives you also 52 centimeters squared. Now, in this prism, if we deconstruct it into a net, you have your 2 sides, you have the center, which is probably the back part, and then you have the other side. Now, the pink part right here goes on top, and then you have the bottom. So this shape is actually a 5-sided shape. So you can't exactly apply the same approach as you did in the previous problem or to a cube. Now if we put the measures on it, it's 3 tall and it's 4 long. And the shape itself is 6 wide. So now you can apply the same idea. So if this is 6 wide, that means this bottom part is 4 long. So this is 4. If this is 6 wide, then the top is 5 long. So now 6 times 5 here gives you 30. 6 times 3 here gives you 18. 6 times 4 here gives you 24. 4 times 3 is 12, and we want half because it's a triangle, so that's 6, and this side is also 6. Once you add these numbers all together, it should give you a surface area of 78 centimeters squared. And finally, let's talk about the last concept, which is volume. Volume is addressing the space inside the shape, the interior of the shape. Another way to think about it is the filling. So how much water can fill it, how much sand can go inside, how many grams of rice can go in the jar, etc., etc., etc. To solve the volume for a normal cuboid or a cube, it's just very simple, straightforward. You take your three dimensions, length, width, and height, and multiply them together. So in this case, you have your volume will be equal to 3 times 3 times 3, which will give you 27. And because it's volume and we multiply three dimensions together, it's centimeters cubed. Volume is always a cube because you multiply three dimensions together. Now for a prism, sometimes they're unusual. To find the volume, there's many approaches, but this is one of the approaches, is you take the area of the cross section and you multiply it by how long it is. So what I mean by the area of the cross section is basically if you look at the shape and you're to cut it into even slices of cake, the cross section is right here, meaning that if I were to look at it, the shape would look like that. So that means that the area is basically this. We notice that it's 1, 2, 3, 4 squares. So the area of that cross section is an area of 4. Now we want to multiply it by how long it is. And the area is already in centimeters squared, so we don't have to worry about that. The length, it's 2 squares wide. So you double it times 2, which gives us 8, and it's centimeters there, centimeters cubed. And that's our final answer. So just to give you an idea again, volume, area of the cross section, and the length. So in this cuboid, this is the area of the cross section. In this unusual shape, the area of the cross section looks like this because you slice it into pieces of cake like that. And then in this case, it's the L shape of the step ladder because you want to cut it into even slices of cake. This is how you do it. So, can you pause and try to find the volume of these two shapes? So for the first one, this is straightforward. 3 times 4 times 2, giving you a volume of 24 centimeters cubed. In the second one, the area of the triangle is 3 times 4, which is 12, and you cut that in half, divided by 2, which gives you 6. So this part right here has an area of 6. Now, I have to go ahead and multiply by how long it is. So 6 times 6 becomes 36 centimeters squared. Now, of course, this is just one approach. You could have also turned this into a quadrilateral and then cut it in half. So use a strategy that works for you. And that's it.